We're going to be doing data distributions for 10-3. Your learning target is I can find central tendency and create a box and whisker plot. For your warm-up, if you were in class, we would have polled the class to see how many hours of television that you watch or how many hours of video games that you played. But for the video, for this sake, we're just going to go ahead and use this data set of 8, 5, 10, 3, 15, and 25. So let's go ahead and jot those down. 8, 5, 10, 3, let's go back and look, 8, 5, 10, 3, 15, and 25. And we're going to be using those for the remainders of the questions. Measures of central tendency. We're going to use the data to calculate the following means of central tendency. The mean is the sum of the values in the data set divided by the number of values in the set. Another word for mean is average. The work that I would want to see is I would want to see everything added up and divided by how many. Before you start anything, the first thing you must do is put the data in numerical order. So I'm going to start with 3, then 5, then 8, then 10, then 15, then all the way up at 25. So to find my mean, there's 1, 2, 3, 4, 5, 6. You must show divided by 6. You can plug in your calculator 3 plus 5 plus 8 plus 10 plus 15 plus 25, and you would get 66 here. I need to see the sum divided by the total. You must show. You will miss points if you do not. So you get 11 for the mean once you do the division. Your median is the middle value of the values when they're in numerical order, or the mean of the middle two values if there are an even number of values. Since there are an even number, there were 6, that means there's 3 on each side. So 1, 2, 3, right here is where the median is. So I need to take the average of 8 and 10. You must show the average. You must show your work if you have to find the average. I want to see 8 plus 10 divided by 2. So that's 18 divided by 2, which is 9. Your mode is the value that occurs most often. There may be one, more than one, or no mode for a data set. Every number in my data set only occurs once. So in this case, there is no mode. Which measure of central tendency is the true average? Well, that would be your mean. What represents this the best? Would it be the mean, the median, or the mode? Let's think about this for a minute. Would 11 right here be the best representation for this data set? I would actually say that the median would be. And the reason why is this 25. We're going to talk about that 25 in just a minute. But if you're thinking in the back of your head that that's an outlier, you're absolutely correct. We're going to talk about that next. Range and outliers. The range is the difference between the least and the greatest values in our data set. Let's look at our data from before. We had 3, then we had 5, 8, 10, 15, and 25. To find the range, you would do 25 minus 3, which is 22. Again, I need to see that work. It describes the spread of the data. It means if you were on a number line, there would be 22 different tallies. It's pretty far apart. In outlier, you just heard me say the word outlier. It is a value that is very different than the other values in the set. An outlier's effect is on the mean. It skews it to be much larger or much smaller. The way I would tell that this one has an outlier is look at the difference. Between 3 and 5 is a difference of 2. 5 and 8 is a difference of 3. Between 10 and 15 is a difference of 5. But between 15 and 25 is a difference of 10. 10 is double what 5 was. So I can tell that 25 was an outlier. That is why the median was better. And I'm going to put here, the median is better because 25 is an outlier. Now we're going to talk about box and whiskers plots. The following I have here is a list of ages at the time of death of some famous musicians from the 17th, 18th, and 19th century. The first thing that we need to do with these ages is put them in order from least to greatest. When I'm putting them in order from least to greatest, I always like to cross off the numbers once I've used it. I'm going to count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values. When I put them in order from least to greatest, I need to end up with 13 values. My smallest number is 31, pretty young. Then let's jump, see there's no more 30s, let's go to the 40s. I see 46. Make sure you have commas in between your numbers. I don't see anything else in the 40s, but we have a 53 and a 57. Any more in the 50s? Okay, we're at 63, 64, and 65. Next, there's 70. We have a 74, 75, 77, 88, and 89. So let's count to make sure we still have 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Good, we didn't skip anything. So that's always the first thing you need to do. Your second step is to identify the minimum and the maximum. My minimum is my smallest number. It's going to be 31. Your maximum is your largest number, and in this case, it's 89. Now we have to find the median. Because there were 13 numbers, it's odd. So I know if there are 13 values and I need to find the middle, I always think about, well, 12 is 1 less than 13. If I take 12 and I divide it by 2, I get 6. That gives me 6 on each side. That's not my median. I'm going to go ahead and erase that, but that means on my median there's 6 on each side. So I'd go 1, 2, 3, 4, 5, 6. Median, 1, 2, 3, 4, 5, 6. So my median equals 65. Now we're going to talk about some quartiles. Q1 is the median of the lower half of your data. So if I look at my data, my lower half I just circled. This is the lower half. Notice it does not include the median. It stands alone. So I need to find the median of this lower half. So Q1 would equal, there's 1, 2, 3, 4, 5, 6. If I split that in 2, this would be Q1. I have to find the average between 53 and 57. So you'd have to do 53 plus 57 divided by 2. When you add them up and divide by 2, you're going to get 55. To find Q3, it is the median of the upper half. So my upper half is above the median. Again, there's 1, 2, 3, 4, 5, 6 values. So Q3 is going to be right there. To find Q3, I would have to do 75 plus 77 divided by 2, which is going to give me 76. You need to make a number line and plot the 5 key points. I'm going to go ahead and over here make a list. My minimum, we got to be 31. Q1 was 55. My median, we got a median of 65. Q3 was 76. And my maximum was all the way up at 89. So I need to make a number line that ranges from 31 all way to 89. So I'm going to take a really nice straight line. I'm going to make it pretty long because I have to go pretty far. And I'm going to start at 30. And I'm going to go by fives. 31, 2, 3, 4, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 2, 3, 4, 5, 66, 67, 68, 69, 70. Looks like I'm going to have to move to put my data in a better spot. So I'm going to go ahead and move that. Okay, so I moved my box of points up just so I had some more room so that now I can keep my number line going. 71, 2, 3, 4, 5, 76, 7, 8, 9, 80, 81, 2, 3, 4, 5, 86, 7, 8, 9, 90. So my box and whisker plot, I need to put a dot. All of them go above. So my minimum's 31, and I want to see the number 31 above it. Then my Q1 is 55, so 55, and I want to see 55 above it. Then my median was 65, a little dot above, and 65. Q3 was 76, I wrote it above, 76. And my maximum was 89. Now it's called a box and whisker plot. Your box goes from Q1 to Q3, and you also draw a vertical line through the middle, the median. Draw a whisker out to 89 and a whisker to 55. There you have your box and whisker plot. Now we're going to talk about interquartile range. Interquartile range represents the middle half of the data. You do it by doing Q3 minus Q1. If we look back at our last question, Q3 was 76, Q1 was 55. That's saying the range from 76 to 55. This range is your interquartile range. So you would do 76 minus 55, which equals 21. What percent of data falls in the interquartile range? Well, 50% does. If you look back, a box and whisker plot has 1, 2, 3, 4 spots. So if you have 2 here, 2 out of the 4 would be 50%. What percent lies above Q3? Well, each portion would be worth 25%. 25, 25, 25, and 25. That's why these two combined was 50. So above Q3 would be another 25%. Last but not least, we're going to make a box and whisker plot of even numbers. The first thing you need to do is put your data in order from least to greatest. Go ahead and do that and then go to the next video to watch how to do this one.